Hi everybody, today we are going to start a new topic 10.5 which is finding the area using definite integral. Let's have a look. First we have a function which is y is f of x given as a graph in the red one. Next we are going to get a line which is x equals a. The next we are going to get line x equals b, and we are going to find the area which is bounded by x equals a, x equals b, the curve, and x-axis. Here it is, the area. Okay. You know that it is x-axis and y-axis. So we are looking for exactly the area of this region. Let me specify A. The area between the curve y is f of x and x-axis, and it is bounded by x equals a and x equals b. It is given by a, the integral from a to b as f of x dx. Again, we have an area which is bounded by the curve y is f of x and the line x equals a, x equals b, and the x-axis, which is the horizontal one. Okay, let's have a sample for this. Exercise 10.5 from your book 1a. In this question, we are going to find the area bounded by the curve with y is 3x squared, x equals 2, and x-axis. Find the area bounded by y is 3x squared, x equals 2, and x-axis. As you can guess, we need to sketch the graph of the function to figure out what area it is built. Firstly, remember that y is 3x squared is a parabolic function. Let me show the coordinate system, x and y. And 3x squared, as we said, is a parabolic function, and it is passing through the origin. The left part, right part. You remember that the coefficient 3, which is positive, so we could say that arms are looking upward. In the next, we have x equals 2. X is 2 is a line which is passing through here. So this is the line where x equals 2. And lastly, we have x-axis. You know that x-axis is already given as a part of coordinate system, which is the horizontal line. What about the area where it is created? Here it is. So we will find out what is the area of this region. To find the area in terms of definite integral, you need to know two things. First, the function. Second, boundaries, upper and lower limits. In this question, we have the function, which is already given, and boundary which is axis 2. And what is the starting point, which is origin. So the area equals from 0 to 2. It means the graph, which is 0, and it goes to 0, 2, and the area from 0 to 2. and the function is here 3x squared dx. That's all. Accordingly, 3x squared, we know how to integrate this over 3 from 0 to 2. You see that we have a cancellation here. So we got x cubed from 0 to 2. Let's try in order. 2 cubed minus 0 cubed, which is 8. So we say that the area of the region bounded by the curve and a line and x-axis, it has an area 8. If it is given, we say square unit. Let's have a look at another sample. Exercises 10.5, page 185, 1b. In this question, it is similarly given a function. We have the function f of x, or we say y, which is x times 6 minus x. The difference first and second questions, in this we are given that it's a factorized form. Okay. We are going to find the area bounded by this curve and x-axis. Firstly, let's show the coordinate system. In this, we have the function y is x times 6 minus x. In fact, we could say that this is a function such that 6x minus x to the power 2. Okay, the question is such that the behavior of the parabola, I mean the arms are looking upward or downward. How to decide that? Of course, it's enough to know the coefficient of x to the power 2, which is minus 1 x to the power 2. So we could say that the function is something like that. It means arms are looking downward. To sketch the graph of the function, first let's find intercepts. To find intercepts, we know x is 0, we get y is, let's substitute 0 times a number 0. If y is 0, what do you get x? Here it is, we need an operation 0 equals x times 6 minus x. It means this can be 0 or that can be 0. It means 6. So x is 0 and x is 6. These are intercepts. It means that the graph is passing through these points. Since it's a parabola, we can easily graph the function. It's passing through origin. Okay, this is our graph. The question is asking, what is the area? So we say easily, the area is here. How to find this area? Let's write this area in the terms of integral. Just you need to remember the starting point and the finish point. Area means the integral of the function from 0 to 6. Let's go. Area equals the integral from 0 to 6, and the function is x times 6 minus x. And we know that x times 6 minus x, in fact, it is such that 6x minus x to the power 2. So we can integrate this function. 6x to the 2 over 2 minus x squared has integral x cubed over 3. And since it's a definite integral from 0 to 6, we have a cancellation here. It means x squared minus x cubed over 3 from 0 to 6. So let's substitute for 6 and 0 respectively. It means 6 cubed over 3 minus 0 squared minus 0 cubed over 3. So from here we got 36. Pardon, we have here 3. I forgot it. 3 times 6 squared, which is 108, minus 6 cubed over 3, which is 216, divided by 3, 72, minus 0, it means 36. So area equals 36 units square is the area which is bounded by the function x times 6 minus x and x-axis. Let's have a look at another sample, 2a. At the same page, exercise 10.4, 2a. From minus 1 to 2, 6x squared minus 2x dx. I mean that we are going to write the function and then we are going to find its definite integral. In this question, we are going to find the area bounded by the curve and the x-axis. The curve is given such that 3x squared minus 3 and x-axis. Okay, first we need to sketch the graph of the function. Similarly, we have y is 3x squared minus 3 is a parabolic function. To graph parabolic functions, firstly you need to get intercepts. To find intercepts, we are going to follow the similar method. If x is 0, what do we get y? If y is 0, what do we get x? Okay, we can try easily. If x is 0, we get 3x squared minus 3, which is minus 3. If y is 0, we got plus 1 and minus 1. So I can write the points minus 1 and minus 3. So we have 1, 2, 3 points where the function is passing through. We know that this is a curve and 3x squared, the coefficient 3 is a positive number, so the graph will be looking like this. It means arms are looking upward. So let's graph the function. So here it is, coming and passing through. What about the area? Where the area is axis. So we have x-axis here and we have the graph. The area which is created by x-axis and the curve is here. Next, we are going to write the area in the terms of definite integral. easily the area equals integral from where to where. So the x-intercepts are -1 and 1. So the graph is defined from -1 to 1. And the function is given 3x squared minus 3. So let's get integral of this function. Okay, let's apply the integration rules. 3x squared has integral over 3 minus 3x. Okay, the function is defined from -1 to 1. We have a cancellation here. X cubed minus 3x. So -1 to 1. So if we try for 1 cubed minus 3 times 1 minus -1 cubed minus 3 times -1. If we cancel this, we got on the left part -2, on the right part minus cube is -1, and here it is 3 minus 2. Yep. So the final answer is -4. In fact, we know that the area cannot be a negative value, so we are going to get just positive value. So we say that area equals 4 square units. The next question, exercises 10.5 2b. Similarly, we are going to find the area which is bounded by the curve which is given and x-axis. Sorry, I changed the function. Bounded by the curve y is x times x plus 2 times x minus 1 and the x-axis. We are going to follow the same procedure. First, let's sketch the graph of the function. To sketch this function, firstly, let's find intercepts. Like the previous one, we are going to get x is 0, but we get y. I think this is really easy. 0 times any number is 0, it means that 0. So we can say that the function is passing through origin. This is the first point that I'm going to use. And second, if y is 0, what do we get x? To figure out this, we need to get some calculations. X times x plus 2, x minus 1. It means that 0 equals x plus 2, x minus 1. So let's use our early knowledge. What number times what numbers equals 0? It means I can say this is 0, this can be 0, in this the second one is -2, and the last product could be minus x minus 1, which is 1. Yeah, so these are possibles. Possibility 0, -2 and 1, where the function becomes 0. Let me show them. This is -2. 0 is already given, which is origin, and 1. The graph is going to pass through these points. Okay, the question is such that where the function starts and passing through. The behavior of the function is x cubed x times x plus 2, x minus 1. So let's go. Y is x times x plus 2 and x minus 1. Here x times, let's multiply x plus 2 and x minus 1, and then let's multiply by x. Here we got x squared minus x minus 2. Finally, we have the function y is x cubed x squared minus 2x. Let me check my steps. plus 2x minus x, here it is plus, yeah. Okay, y is x cubed plus x squared minus 2x. Okay, you see that this is the leading coefficient 1, which comes from positive 1x cubed. To figure out this, we can find the limit of the function where x approaches positive infinite. Similarly, limit where x approaches minus infinite. It means you can substitute infinite, positive infinite for x, infinite cube, which is positive infinite. And if we substitute minus infinite for x, we get minus infinite cube, which is minus infinite. Basically, we can say that the function is starting from minus infinite and passing through some points and goes to positive infinite. Let's graph the function. So the function is coming such that turning, passing through 0 and positive infinite. Again, it starts from minus infinite, passing through the point, origin, and 1 goes to positive infinite. Okay, the question was such that find the area. The area is bounded here, the first area and the second area. So since there are two areas, let me define them, the area 1 and area 2. Let's find the areas separately. The area 1 is definite integral from where to where. So you see that it starts from minus 2 up to 0. So upper and lower limit I can define from minus 2 to 0. And the function we already knew, x times x plus 2 times x minus 1, or I can say just x cubed plus x squared minus 2x, we already show it, dx. In the second, the area will be something like that. Here it starts from 0 to 1. From 0 to 1, we have the same function, x squared minus 2x dx. Okay, if we calculate the area 1 and area 2, we got area 1 8 over 3, area 2, which is minus 5 over 12. The value becomes minus 5 over 12, but we said that the area cannot be negative, we will just take positive values. So the question is find the area. I can say that area total equals area 1 plus area 2, which is 8 over 3 plus 5 over 12. It means 37 over 12. Okay, this is a long question. Let me repeat one more time. The question is find the area bounded by the curve and the x-axis. You need to sketch the graph firstly, and then you need to figure out what areas are created, area 1 and area 2. To find area 1, we are following the same procedure from minus 2 to 0, the first area. The second area is from 0 to 1. And then you will apply the basic integration rules, integrate the first function and second function with the given boundaries. We get area 1 and area 2. The question is find the area. It means we will find the total area. If you are having difficulty with graphing, sketching the graph, you can get a help from different programs we talked before. Remember that you can use Desmos calculator. Here I have a sample. X times x, which is that, plus 2, and x minus 1. Okay, here you see the function space interior -2, origin, and 1. And the areas will be, the first area is here, area 1 we defined, and area 2 is here. Okay everybody, for today that's enough. Hope to meet you again with you. Goodbye.